greenhouse effect is brought about by several gases, and these gases, namely carbon dioxide, methane, nitrous oxide, chlorofluorocarbons and tropospheric ozone. Carbon dioxide plays a major role and accounts for about 55% of change in the intensity of greenhouse effect. Chlorofluorocarbons contribute 25%, 15% by methane and 5% nitrous oxide are produced respectively. The role of ozone towards enhancement of greenhouse effect is yet to be quantified. In the year 2005, the average concentration of carbon dioxide were about 380 parts per million, that is expressed in ppm. Prior to 1900, the carbon dioxide concentration was about 280 ppm. Due to increased urbanization and industrialization, the carbon dioxide concentration has enormously gone up, which is entering the atmosphere. The main reason for emission of carbon dioxide is due to burning of fossil fuel, combustion for transportation, generation of electricity, space heating and cooking, deforestation and destruction of biodiversity. Emission due to fossil fuel combustion accounts for 65% extra carbon dioxide now found in atmosphere. The remaining 35% is derived from the conversion of prairie woodland and forested ecosystem primarily into agricultural ecosystem, which can hold 20 to 100 times more carbon dioxide per unit area than agriculture system. Chlorofluorocarbons are artificially created are the strongest greenhouse gases. These gases are also known to make holes in the ozone layer, which has far-reaching effect on the human beings. General decline in global stratospheric ozone levels over the last 2 decades has caused many nations to cut back on their production and use of these chemicals. As per the Montreal Protocol Agreement, by 46 nations established a pact and immediate timetable for the reduction of chlorofluorocarbons production and its use. The average concentration of nitrous oxide is one of the important greenhouse gas is increasing 0.2 to 0.3 μm per year. The important reason for the increase is due to biomass burning, land use conversion, fossil fuel combustion and soil fertigation. Nitrous oxide is also produced due to conversion of savanna and grassland ecosystem to agriculture field. These processes reduce the amount of nitrogen stored in living vegetation through decomposition of organic matter. When biomass and fossil fuels are burnt, nitrous oxide is released into the atmosphere. Extensive usage of nitrate, ammonium fertilizers to enhance the growth is another source of nitrous oxide. It is difficult to determine the role of ozone in the atmosphere. Concentration of ozone gas are found in 2 different regions of Earth's atmosphere. Majority of ozone, that is about 97%, found in the atmosphere is localized in stratospheric at an altitude of 15 to 55 kilometers above the Earth's surface. Of late, the concentrations of stratospheric ozone has been decreasing because of buildup of chlorofluorocarbons in the atmosphere. Since the late 1970s, scientists have discussed that total column ozone present over Antarctica in the springtime have decreased as much as 70%. Ozone is highly concentrated at Earth's surface and most of this ozone is created as an artificial byproduct of photochemical smog. Green concentration, that is different concentrations of the greenhouse gases are given here. Carbon dioxide, that is carbon dioxide 280 ppm in 1750, and in 2003 it has been increased to 376 ppm and the percent change is 34%. Methane, it was just 0.71 ppm in 1750, has considerably increased to 1.79 ppm and the net percent change is 152%. Whereas nitrous oxide, it was 270 parts per billion in 1750, has gone up to 319 parts per billion, increasing by 18%. Chlorofluorocarbon in 1750, but now it is increased to 880 parts per trillion and net change is, percent change is not applicable here. And of course ozone, it was unknown in 1750 and in 2003 it varies with latitude and altitude.